Namaste everyone, welcome again to the class. Now here we are going to see the problems of the type 0 to infinity e power minus at into f of t upon t into dt. In the last lecture we have seen Laplace transform when the function is divided by t, right? So in the last lecture we have seen that Laplace of f of t upon t, this is nothing but integration of s to infinity phi of s into ds, where this phi of s is nothing but Laplace of f of t. Now Laplace of f of t upon t is nothing but 0 to infinity e raised to minus st into f of t upon t dt. This is Laplace of f of t upon t, and this is equals to s to infinity phi of s ds. Okay, so once I will find Laplace of f of t upon t, then in place of s I can replace a and I will get the required answer. Let us understand this with the help of few problems. Okay, first problem that we are going to discuss is evaluate 0 to infinity e power minus t into sin t upon t into dt. We have to evaluate this integral. Okay, so we will begin with Laplace of sin t. Laplace of sin t, you know the formula, it is 1 upon s square plus 1. Then we will calculate Laplace of sin t upon t. For this, we will integrate 1 upon s square plus 1 between limit s to infinity. This will give me answer as tan inverse s, and the limit which I will use is s2 not defined. So I will put first not defined value, so it will be tan inverse not defined minus tan inverse s. Tan inverse not defined is pi by 2 minus tan inverse s. This is Laplace of sin t upon t. So Laplace of sin t upon t is pi by 2 minus tan inverse s. Pi by 2 minus tan inverse s is cot inverse s. And this Laplace of sin t upon t is 0 to infinity e raised to minus st into f of t is here, in our case it is sin t upon t into dt. Now we have to find the value of e raised to minus t sin t upon t dt. So here in place of s I have to put 1. So here when I put s is equals to 1, I get s 0 to infinity e power minus t into sin t upon t into dt, and here I will get cot inverse. In place of s I will put 1. So cot inverse 1 is pi upon 4, as cot pi upon 4 is 1. So this is my required answer. Simple question. Now let us take another problem. Evaluate. Here I will find evaluate h 0 to infinity cos at minus cos bt whole divided by t into dt. I have to find its value. Now here e power at or e power minus t, nothing is given. So we can assume that it is e power 0 t. So when it is e power 0, its value is 1, and then I can use the above procedure. So for that, let us first find Laplace of cos at minus cos bt. So Laplace of cos at minus cos bt. This is equals to s upon s square plus a square minus s upon s square plus b square. Therefore, Laplace of cos at minus cos bt whole divided by t, this will be equal to integration from s2 not defined s upon s square plus a square minus s upon s square plus b square into ds. Now to integrate it, the derivative of s square plus a square is 2s. So I will multiply and divide by 2. So here I will get 1 upon 2. It will be log of s square plus a square minus 1 by 2. So this 1 by 2 we can take common, and we will write log of s square plus b square, and the limit is s2 not defined. This is equals to 1 by 2 log of, here it is s square plus a square divided by s square plus b square, and the limit is s2 not defined. Now when we put not defined value, it will be 0. So this is 1 by 2. Here we have 0 minus, when we put s, so it will remain as it is, log of s square plus a square upon s square plus b square. So this is equals to, now this is half. Now because of this minus sign, I will reciprocate this inner term. So I will write s square plus b square upon s square plus a square. This is my answer for Laplace of cos at minus cos bt upon t. So therefore, this is the answer for 0 to infinity e raised to minus st into cos at minus cos bt whole divided by t into dt. This I will say that is equals to 1 by 2 log of s square plus b square upon s square plus a square. Now in our question, here e power minus st is not there, so I will put s is equals to 0. So therefore I will get 0 to infinity cos at minus cos bt whole divided by t into dt is equals to, I am putting s is equals to 0. So here I will get 1 by 2 log of b square divided by a square. So we simplify it, we will get 1 by 2 into log of, here it is b divided by a the whole square. So this is 1 by 2 into 2 log of b by a. So this 2 and 2 will cancel, and it is log of b divided by a. So this is my answer, log of b divided by a. Getting it? Okay. Let us solve one more question. I have to prove that. So question is, prove that 0 to infinity e raised to minus t into sin square t divided by t into dt is equals to 1 by 4 log phi. We have to prove that 0 to infinity e power minus t into sin square t upon t dt is equals to 1 upon 4 log phi. So here first we will find Laplace of sin square t. So Laplace of sin square t. Okay, we have to prove that this is equals to this. So Laplace of sin square t, it is nothing but Laplace of sin square can be written as 1 minus cos 2t whole divided by 2. So 1 by 2 I will take common. Now Laplace of 1 is s minus Laplace of cos 2t is s upon s square plus 4. Now I will find Laplace of sin square t divided by t. So Laplace of sin square t divided by t will be equal to s to infinity. This 1 by 2 I will take out. Here it is there is no point in cross multiplication. So here integration of s minus s upon s square plus 4 into ds. Okay, 1 minute. Laplace of 1 is 1 upon s. It is not s. It is 1 upon s. So here it is 1 divided by s. So integration of 1 upon s is log s minus this is 1 upon 2 log of s square plus 4, and the limit for integration is s2 not defined. So this is equals to 1 divided by 4. I will take this 1 upon 2 out, and here it will become log of s square. So log of s square minus log of s square plus 4 will become log of s square upon s square plus 4. S2 not defined. So when we put this not defined, I will get 0. And when I put lower limit, it will be same. So it is minus 1 upon 4 log of s square upon s square plus 4. This minus I will remove, and I will say that this is 1 upon 4 log of s square plus 4 upon s square. So this is the answer for Laplace of sin square t upon t. So therefore I will say that therefore 0 to infinity e raised to minus st into sin square t upon t dt will be equal to, here it is 1 upon 4 log of s square plus 4 upon s square, and limit is, okay, limit already we have applied. Okay, fine. So nothing, this bracket is actually not needed. Now I have to prove that 0 to infinity e raised to minus t. That means I will put s is equals to 1. So put s is equals to 1. We will get therefore 0 to infinity e power minus t into sin square t upon t into dt will be equal to 1 upon 4 log of, in place of s we are going to put 1. So 1 plus 4 is 5. So it is 5 upon 1. So log 5. So it is 1 upon 4 log 5. This is equals to 1 upon 4 log 5. Right? In the same way, whatever problem you get for evaluation, you can solve. So we will see one more question in which hyperbolic function is involved. Okay, that is better. So I have one more problem here. We have to prove that prove that 0 to infinity e power minus root 2 t into sin t into sin hyperbolic t divided by t is equals to pi upon 8. Okay, let us prove this part. Now here, if I simplify this part, okay, 0 to infinity e power minus root 2 t into sin t divided by t into sin hyperbolic t, so into dt. So here I will get 0 to infinity e raised to minus root 2 t sin t upon t. Now this sin hyperbolic t can be written as e power t minus e power minus t whole divided by 2. This is the formula for sin hyperbolic t, e power t minus e power minus t divided by 2. So into dt. Okay, so this we can say that this is equals to 0 to infinity. Now this e power t and this is minus root 2 t. We will club it and we will get e power. In multiplication, the powers will add, so it is 1 minus root 2 times t minus e power. Here we have minus, we will take out 1 plus root 2 times t into, here I have sin t upon t into dt. So now here I will first find Laplace of sin t. Laplace of sin t, I will get 1 upon s square plus 1. Therefore Laplace of sin t upon t, we will get s to infinity 1 upon s square plus 1 into ds, which will be equals to tan inverse s. Now we will apply limit s2 not defined. This will be equals to tan inverse infinity. Tan inverse infinity is pi by 2 minus tan inverse s. This will be cot inverse s. So therefore integration of 0 to infinity e raised to minus st into sin t upon t dt, this will become cot inverse of s. So therefore 0 to infinity e raised to, here we have in this problem 1 minus root 2 t e power 1 minus root 2 t into sin t upon t dt will be equals to, now in place of s we have put 1 minus root 2, so it will become cot inverse 1 minus root 2, and 0 to infinity e raised to minus 1 plus root 2 t. Okay, so here one thing I have to correct, that here it should be minus sign should be out. So if I take minus sign here and outside, then this 1 will become minus and this root 2 will become plus. So it is minus 1 plus root 2, and here it is sin t upon t into dt. This will be cot inverse 1 plus root 2. Therefore we have 1 upon 2 integration of e power minus of minus 1 plus root 2 t minus e power minus of 1 plus root 2 t into sin t upon t dt will be equal to 1 upon 2. Here we have cot inverse minus 1 plus root 2 minus cot inverse 1 plus root 2. As we know the formula of tan inverse A minus tan inverse B, I will convert this cot inverse in tan. See how we can do it. We will add and subtract pi by 2. So here we can say that pi by 2 minus cot inverse. Now what I'm trying to do is pi by 2 I am adding and subtracting. So here first I will take minus pi by 2 here, minus pi by 2 plus this is cot inverse minus 1 plus root 2. Then here I will take plus pi by 2. Then here I have minus cot inverse 1 plus root 2. So what we have done, pi by 2 we have added and subtracted. Now 1 by 2, here I will take minus sign common and it will become pi by 2 minus cot inverse minus 1 plus root 2. Then here it is plus pi by 2 minus cot inverse 1 plus root 2. This is 1 by 2. Now minus pi minus cot inverse is tan inverse, so it will become tan inverse minus 1 plus root 2 plus here it is tan inverse 1 plus root 2. So this is equals to 1 by 2. Tan inverse A minus tan inverse B is tan inverse A minus B, that is 1 plus root 2 minus this minus 1 will become plus 1 and minus root 2 divided by tan inverse A minus tan inverse B is tan inverse A minus B upon 1 plus AB. So in AB we have 1 plus root 2 into minus 1 plus root 2. So this is equals to 1 by 2 tan inverse. Now here root 2 will cancel, so here we have 2 divided by here 1 plus, now a plus b into a minus b is a square minus b square. So this will give me 1 by 2 into tan inverse 2 upon 2, which is equals to 1 by 2 into tan inverse 1, it is equals to 1 by 2 into pi by 4 is equals to pi by 8. So therefore I will say, therefore integration of 0 to infinity e power, we have e power minus root 2t into sin t into sin hyperbolic t upon t dt is equals to pi upon 8, hence proved. Right? So you can solve problems like this. Now we will stop our lecture here. In the next class we will see some problems in which Laplace transform of derivative is involved. Thank you.